Alright, welcome. In this video I'm going to be telling you about rate in, rate out free response questions in AP Calculus. And just to remind you, the big things that we learned from last time was that we can find an ending value of a function by starting with the starting value and adding up, adding in the accumulation of some sort of rate of change, right? That f of b is f of a plus the integral from a to b of f prime of x dx. Okay, we also learned that if we're given some sort of rate function, some rate of change, we can find the total by integrating that rate. Those are the two big things from last time. Now today we're going to have kind of like situations where we've got a rate of addition and a rate of subtraction. So suppose you've got yourself like an ant hill or something, an ant colony. And it's the type of ant colony where, there are ants coming in to the colony or to the hill to bring back whatever they brought, and there's also ants leaving to go out to find more food or whatever. Okay, so you've got a rate. So the big four facts that you need to know today are how to find total in and total out by integrating rate in and rate out. How to write a total function, because those are oftentimes not given to you. You have to be able to cook up your own function, define by an integral to give you the total amount of something, say ants in the hill or whatever. And then we also need to know about the total rate of change, which is this one, that the total rate of change is rate in minus rate out. And so we're just going to work a few examples of actual free response questions to show you how this goes. Okay, so the first example is from 2019. It was from the Calculus AB exam. It was number 1, so it required the use of a calculator. And fish enter a lake at a rate modeled by the function e of t. They're leaving the lake at a rate modeled by L of t. Both E and L are measured in fish per hour, and T is measured in hours since midnight. I remember doing this one in class, and this one was a little weird because they didn't say anything about how many fish the lake started with. So we're just going to have to assume it starts with 0 fish. But let's just jump in and do these. Now the first thing I'm going to do on these problems is I'm going to put rate in y1. So I'm going to put 20 plus 15 sine. As soon as I hit that sine button, I'm going to check to make sure I'm in rating mode, but I am, so it's good, of pi t divided by 6, and in y2, that's L of t, that's 4 plus 2 to the power of 0.1 t squared. Okay. Now, I'm also going to put y3 equals y1 minus y2, because like I showed you before, we're interested in situations where we're considering rate in minus rate out. We're also interested in integrating rate in minus rate out. So oftentimes it's convenient to just already have y3 equals y1 minus y2, total rate of change is rate in minus rate out, in your calculator so that we can do that. Okay. Now, first they want to know the total number of fish that enter, so that's the total in. Okay. I just told you, and I'll just remind you again, that the total n is going to be the integral from, in this case, 0 to 5, rate n with respect to time. Well, what that's going to be is that's going to be the integral from 0 to 5 of e of t. Nearest whole fish. Okay, well we can do that. So we're going to integrate by calling our math 9 from 0 to 5. E of t I had stored in y1, so I'll call on that. And I'll get myself 153 fish. Okay, that was part A. B, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? All right, I feel like there's kind of two ways you could attack this. For me, I don't know, it's hard for me to know what y'all would think first because, I'm an AP Calculus teacher. I've been doing this for a while, and I see average, I'm thinking average value, pretty much always. But for y'all might be thinking, well, I'd find the average by getting the total number of fish that left from t equals 0 to t equals 5, and then dividing by 5, right? So what I'm proposing is that's actually the same thing. So I'm going to just say the average value of L, that's going to be 1 over 5 minus 0 times the integral from 0 to 5 of L of t dt. But the thing about this is that, you know, this integral is the total number of fish that left, and you divide by 5, it's going to be the same thing, right? So what is the average number of fish that leave the lake per hour? Okay, so 1/5 is 0.2, you can't even really see that, times the integral from 0 to 5 of L of t, I've gotten y2, and I get 6.059. Okay, for part C. At what time t for 0 to 8 is the greatest number of fish in the lake? Justify my answer. Okay, so we're looking for a maximum on a closed interval. That's where we're going to do the candidates test. All right. Now, we don't really have a formula or a function for number of fish in the lake. So that's where I'm going to start by defining myself a new function. I'm going to say, oh, something on it. Let's say let n of t equal the integral from 0 to t. Now, I'm not going to add anything to the left of this because I'm assuming that the lake started empty because I have no reason to believe otherwise. Integral from 0 to t of e rate in minus rate out. So I'm just going to call it x for now. That's fine because t is already committed. Okay, this is going to represent number of fish at time t. Okay. I am going to need to consider n of 0, n of 8, and n at any critical point of n. Okay, so we need to just say, all right, I'm interested in considering t and n of t. I've got plenty of room. I need to consider 0, I need to consider 8, and I need to consider any place where n prime of t equals 0. Well, I'm going to need to write n prime of t. That's where I take t and I throw it in wherever I see the dummy variable. And that would be e of t minus L of t, or we just know that the rate of change in the number of fish in the lake is going to be rate in minus rate out. I'm interested in where this is equal to 0 on the interval 0 to 8. So what I'm going to do is I'm going to graph y3, right? Because I've got y3 representing that rate in minus rate out function. So I'm going to go over here. I'm going to actually turn off the graphing of these two things because all I care about is where y3 equals 0. So I'm going to change the window to be 0 to 8. And hopefully I'll find maybe just 1 point, right? That would be great. I would love that. Because then I'd only have to, evaluate that integral at 1 extra point. All right, yeah, there we go. Okay, looks promising. Okay, good, yeah. So we're going to calculate a 0. Looks like, 4 is definitely to the left of it. I think 7 would be to the right of it. That's going to be 6.20356444. Now, let's see. At what time t is the greatest number of fish in the lake? You got to go back to the question. So your answer is going to be a value of t, so we're okay to round this. Okay, had we wanted the actual number of fish, I would recommend that you carry all of those decimals because that time value is not your answer. But we'll have way more to say about that as we move forward in the course. So 6.204. Okay. Now I'm going to need to compute n of t for all these. Now, the integral from 0 to 0 of e minus L, I don't even have to know what e minus L is. That's going to be 0. Now I'm going to go over here. And if I'm integrating from 0 to t on e minus L, I'm just going to be integrating y3. So I'm going to say the integral, math 9, from 0 to 8 of n is, it's the integral of y3. So that's what y3 is rate in minus rate out, e minus L is rate in minus rate out. Okay, we'll let that happen. 0.920. Okay. Pretty sure I remember this being a relative maximum, and if it's the only interior critical point and it's relative maximum, it will be the absolute maximum. But I'll just check just to make sure. 6.204, and I'll get 135 fish. That's good. Okay, so 135.015. Okay. write a little conclusion. The greatest number happens when t equals 6.204. That's all I'll say about that. All right, and then for part D, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain my reasoning. Okay, I'm going to just grab a quick Post-it note and kind of paste on top of all of this work because this is not going to take long. All right. So the total, or is the rate of change in the number of fish in the lake. This one is very tricky. I almost got tricked by it again. I think I did get tricked by it in one of the sections. I think I may have read that is the number of fish in the lake increasing or decreasing at 5 a.m. That would be interesting. Well, the rate of change in the number of fish in the lake is n prime of t. And if I want to figure out whether this rate of change is increasing or decreasing, I need to take the derivative of this thing. So n double prime of 5 equals e prime of 5 minus l prime of 5. And now I could use a calculator to compute it that way. But I could also know it's just going to be the derivative of y3 at time t equals 5. So I'm going to call for the derivative using math 8. Take the derivative of the rate of change to see if that rate of change is increasing or decreasing. At the time where t equals 5, I get negative 10.723. Which is a negative number. So I'm going to conclude that since n prime is the rate of change of number of fish in the lake, well, that rate of change is decreasing because its derivative is negative. Okay, that's example 1. All right, the second example I want to work with you is from 2017's AB exam. It was number 2, so it's also going to require a graphing calculator. And so when a certain grocery store opens, it has 50 pounds of bananas on a display table. The customers are removing them at f of t, and then after 3 hours, store employees are realizing that they're running out of bananas, and so they start restocking at a rate of g of t pounds per hour. And they're going to ask us, kind of a variety of questions there. Okay, so just I'm going to plug the rate in into y1 and the rate out into y2. Wait a second, that's not the rate in and the rate out. F of t is the rate out and g of t is the rate in. Okay, that's a little tricky. So what I'm going to do is I'm going to actually change this to rate out, or rate in minus rate out. Okay, that's what we want, rate in minus rate out, always. So I've got that all in there, and I just need to remember that y1 is the rate of banana removal. So, all right. So how many pounds of bananas are removed from the display table during the first 2 hours the store is open? All right. Well, the total out is going to be the integral from 0 to 2 of the rate out, which is f of t dt, the rate of banana removal. Okay, we can do that. Okay, so it's going to be y1. So math 9 from 0 to 2 on y1 with respect to time is going to be 20.051. Okay. Find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. Okay, so I'm going to kind of try to do this at once. At t equals 7, 7 represents hours. Don't forget the units of the independent variable as well. Okay, at t equals 7 hours, okay, f is the rate of banana removal. And then I'm going to put increasing or decreasing, because, but I need to take f prime of 8. So I've got f and y1, so I'm going to take the derivative of y1 at the time when t equals 7. I'm going to get negative 8.119. So is decreasing by 8.119. Remember, I can round or truncate, doesn't matter. And what are the units of f? Pounds per hour divided by units of t is hours. So the banana removal rate is decreasing 8.119 pounds per hour. And that would make sense. The rate of change for rate is going to be, pounds per hour per hour. Okay, then part C is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5. Well, the number of pounds, which I feel like I'm going to need anyway, is going to be, well, the number of pounds at the beginning, so 50, plus the integral from 0 to t of, this one is, okay, so this one has a little offset in the time domains, so I need to integrate these separately. So 50 plus 0 to t of f of t, and then minus the integral from 3 to t of rate out. And I lost my dt. Okay, what I'll say about this is that this is only a valid formula where t is greater than or equal to 3, right? And, if t is less, just use the first two parts of this formula, and I'm realizing, what are we going to actually, how many pounds of bananas are on the display table at time t equals 8? Yeah, I think that's what I'm going to do. I'm going to switch this to, I'm working D now, and we're going to be considering 0 to 8. Okay, so that'll probably be the thing to do. Yeah, so this is part D now. The number of bananas at time 8 is 50 plus the integral from 0 to 8 of f minus the integral from 3 to 8 of g, because the employees only started restocking at t equals 3. So, but again, I've got the plus and minus, and okay, I don't know about y'all, or, maybe since y'all are new to this, it's not a big deal. For me, I'm used to, rate in minus rate out, putting rate in y1 and rate out in y2. But f is the rate of banana removal, so we would need to subtract that one and then add that one back in. Okay. So I'm going to clear that out. 50 minus the integral from 0 to 8 of rate out, which I put in y1 with respect to time, plus the integral from 3 to 8 of the rate of banana restocking, which was 2, and I'll get 23.347. Okay, that's the number of pounds of bananas on the display table at time t equals 8. All right, for part C, okay, at time t equals 5, the rate of change in prime of 5 is going to be, well, that'll be g of 5 minus f of 5. That's rate in minus rate out. Okay, so y2 minus y1, which I've already stored in y3. So maybe I'll just call for y3, since I didn't really need to use it this time, and I'll plug in 5, rate in minus rate out. And that's going to be, just make sure, I don't know why I don't believe myself, but rate in minus rate out, and is negative 2.263. Okay, so equals negative 2.263, which is a less than 0 number, so I can conclude that the number of pounds is decreasing at t equals 5. All right. And that's the second one. Okay. Let's see what else we got. I printed out a couple of more free response examples for you, but I'm looking at them and I'm realizing that it's, the parts of those problems that I printed out are no different from the parts of the problems I've just already worked for you. So I think at this point I've shown you what I need to show you, And you need to just go out and work a bunch of these rate in, rate out for your response questions. And the more of these that you do, the more comfortable you'll get. And I need you to be comfortable with these because this is pretty much a guarantee for your AP exam. There's almost always a rate in, rate out for your response question on the AP Calculus exam. So, I think at this point, you just need to get to practicing.